Steffen Bollmann, with a talk entitled Neurodesk, Reproducible Neuroimaging for Anyone or Everyone, even, anywhere. So after a PhD on multimodal imaging at the University of
Oh, did we lose Ashley?
I think we did lose her. I thought it was my internet.
Yeah, me as well. Yeah.
No, I think we all looked. Okay, well, I'll just take over from here then. Yes, welcome everyone. So yeah, my name is Steffen Bollmann. I'm a senior research fellow at the University of Queensland. I work at the School of Electric Engineering and Computer Science and at the Queensland Digital Health Centre. And yeah, I'll talk about Neurodesk today, which is a project led and built by a big community. So I want to start with a thank you to the global Neurodesk community, the users of Neurodesk community, the developers of Neurodesk, and the MRITogether team for putting together such a fantastic event. I know how much work it is and how much effort goes into this. So I really wanted to acknowledge that here at the first slide. And yeah, just a little bit of statistics with Neurodesk. So we currently have about 1,200 monthly users from over 60 countries. So I think we can really say, oh, there's Ashley's packets coming through. Okay. So yeah, so we have more than 1,200 monthly users from over 60 countries. We see more than 19,000 people have downloaded Neurodesk and run it on their computer. And it's used in lots of university courses for teaching and for neuroimaging analyses, or for teaching neuroimaging analyses. And then also after people learn in workshops Neurodesk and learn how they can do analyses, they continue using it in their work. And this is really fantastic to see. So I mentioned already it's a global community. So MRITogether is really the perfect platform for our project. It's really started in Australia, 2020, and you heard the origin story of Neurodesk yesterday in MRITogether presented by Eswin, who's the senior author with me shared on the paper that we produced. And you will hear more about Neurodesk tonight from Tui, who's a PhD student on a project and who did a lot of work on this. I will showcase some of the things she's done as well. But then, yeah, we have lots of people who contributed to the project over the time. And we have lots of companies who support us, like AWS and Jetstream and AGI, and funders who support us, like Wellcome Trust and the Chan and Zuckerberg Initiative and AIDC, and of course, the University of Queensland with the Health Accelerator. So it does take a lot of people to get such a project off the ground and to keep it running. So I just wanted to acknowledge that. And what are we trying to do? So the challenges that we see in open science, or that we saw in open science, is really the first one is non-reproducible workflows. And we've already heard a lot about this. The challenge really is you run the same analysis and you get different results. And this is just suboptimal because it just introduces noise. It's not really what we want. It also means that sometimes a simple thing is you give someone a script and they should execute it. It just doesn't run on their computer. So I even mean simple things like this, right? This just should work. And that's something where we said we should be able to solve that. The other challenge is people want to run these analyses on different computers. So their notebook, their HPC cluster, a cloud provider, secure environment, wherever. And that was really, really, really hard before Neurodesk, because you had to install these tools on every system again and again. And I'll go more into detail about this later. Then data management. We know how important data management is, right? We have to organize data in specific standards like the BID standard or other lab standards that help us to find data and also make sure that other people can reuse this data later on. So we wanted to make this as easy as possible as well. And then also data storage and privacy. Where do we store this data? How do we keep it secure? But also, how do we share this data to the right people or to everyone? And how can we support people in doing that? And that's really the big problems that we're trying to tackle with Neurodesk. So I just want to show a little bit more about this portability problem. And this is really something I faced myself, because there's this amazing tool set of open source software, right? We've got Afni, FreeSurfer, FSL, all these fantastic tools. But then the challenge is you try to install it on your notebook. And if you have a Windows notebook or a Mac notebook, a lot of the software doesn't work. On your lab workstation, you often have Linux installed, and there you don't have admin privileges, so you can't install a lot of these packages. Secure environments, they often run with Windows or Linux as well. Again, you can't install anything in there because they're secure, they don't have internet connectivity. So how do you get your software in there? In cloud providers, you commonly run Linux, but again, it's sometimes weird Linux distributions where you can't easily install things. high-performance computing cluster. You can't run apt-get install. You can't run yum install. You just can't install packages there. You don't have sudo permissions. So you often have to contact the administrators to install stuff for you. And then a week later, they come back to you and say, oh, they couldn't find the software. So it really creates a lot of friction. And also, let's say you got something really cool. You got a pipeline. You want to run it on your MRI scanner. This is days and months of work these days because you have to implement your analysis in the vendor framework, which is often C++ and lots of libraries. You need to compile it. You need to go through approval process to even get these software tools. And it can take many, many months to get anything working there. And we thought this is really, or I thought this is really annoying. Let's do something about this. And this is what Neurodesk provides today. So I'll quickly explain what it is. But the main core part of Neurodesk is really neurocontainers. And what is this is we take containers, so-called software containers, and we package all the things we need inside these containers. So free surfer, field trip, fMRI prep, everything you can think of. And then we have an accessibility layer that makes this accessible to all the other platforms. But first, let me explain what a container is. And a container is really something that revolutionized how cloud computing works these days. So pretty much every website you see on the internet is served from a software container. And the magic thing they do is they isolate dependencies from each other. So in a typical system, so let's say Ubuntu 20.04 is a Linux system, you install packages. So for example, you install Conda and you install VS Code and then you install MNE, which is a library for example, MEG data analysis. And this depends also on Python 3.10 and Conda depends on that. And then you have lots of libraries that also needed to make this work. And this is usually the stuff you install with apt-get or yum install. And the challenge there is that if one of these things get updated or upgraded, things break because they expect these things to be there and to be there in the correct version. And if they don't break, they give you different results, which is really annoying. And this is where containers come in. So containers take these dependencies and they put them in a box. And this box, you can now move to other systems. And the cool thing is, you can use different versions of this software in these containers. You can package them and you can have them in parallel running next to each other, which isn't possible without containers. And then you can run them on Windows, on macOS, on Linux. And the cool thing is on Linux, this is natively implemented in the kernel. These are kernel features that exist by now since almost 20 years. So it's a very mature technology. On Windows and macOS, this is using virtualization and it brings a Linux kernel to Windows or macOS to make that possible. But these virtualization technologies also got really good in the last years. And these virtualizations are very small, very lightweight. So you don't feel that you're starting up a virtual machine. So it's very nicely integrated these days. So it all feels very native. And then, as I said, we can now take these containers. And if you used containers before, you know how annoying they can be, right? You have to either figure out what runtime you're using, Docker or Podman. If you're running on a normal system or on an HPC, you need Singularity and Aptana. So you have to understand what systems to use where and how to call these containers. They all have different command line parameters, which is really annoying. So we wanted to make this really easy. And we built this little thing here we call accessibility layer. And this was actually a lot of work. But what it does in the end is it makes it really transparent for people. You don't have to think about what technology you're using. It just works magically. And then we bring this in two environments. So first we have a graphical environment, which we call Neurodesktop. And this runs Linux, macOS, Windows, or on the cloud, for example. And we have a command line interface, which runs, for example, on a high-performance computing cluster or on a terminal or on a Google Colab notebook. And the distinguishing thing is you don't have a graphical user interface, really, so you have to live with other tools. And I will showcase this in a little bit. The little script that goes here between computers, this is actually the new feature that Neurodesk makes possible. You can now write analysis on one computer and you can move it to another computer and it will just run there as well, give you the same results and just work. And this wasn't possible before Neurodesk. So the easiest way to get started with Neurodesk is to go to our website, neurodesk.org, and select what systems you have. And then we guide you towards the setup that should work best for you. And if you can't find what you're using, let us know and we'll happily add it. And we also have a very quick way of getting started up here. You can just decide, I want to run it locally on my computer. I want to run a hosted version that runs in the cloud. And this really differentiates where you want to run it and how sensitive your data is. And then we help you and get started with this. So once you do this, you get this Neuro desktop, which is a normal Linux desktop with all the tools magically available. All software is ready to go. So you just click on it, you start it, it just works. There's no dependency issues between packages. It allows reproducible analyses. The whole thing is only 1.5 gigabyte in size, and I'll show later how we do this. And just quickly, software is streamed on demand. So actually the software is not installed in there. It's just all, when you click on it, it actually gets downloaded to a computer. And this desktop allows us to support full graphical user interfaces. And I will show this in my live demo later. We also have a high-performance computing cluster interface where we can run Slurm jobs and we can just run really huge analyses with our containers. And we support Jupyter interfaces. And I'll just sort as things in the chat coming through. I'll just quickly check. Okay, that's all good. So we have these Jupyter Lab interfaces where we can use computational notebooks, and this also works for Google Colab, for example. Then adding these tools is still a little bit difficult, but we try to make it easier, and we will make it a lot easier in the next years. But it's currently a bash script that you write where you say what you want in there. And then we have automation on GitHub that takes these containers, builds them, makes them available to everyone. So I already said this actual container that we're running is only 1.5 gigabyte in size. And then we stream 600 gigabyte of software on demand. So whatever you open will get streamed to the computer. We do this through a worldwide distributed network of computers. A lot of them are hosted by the Open Science Grid. And another big part is hosted by AWS. And there's one quick question in the chat that I quickly want to answer. How well does Neurodesk work with Windows OS? We support all operating systems. So we support Windows, Mac, and Linux, and it works really well on Windows OS. The only thing, a little caveat there, if you process millions of files that are stored on Windows, it can become a little bit slow. So a good way is copying the Windows file system over to the Linux file system and then process these data there and then copy the results back out. That's the only caveat with Windows. That's just a limitation of the Windows file system. But yeah, then we basically stream our software, and then the users select a server that's closest to them, and then they get the same software on their laptop, on their desktop, on their HPC, and then our software just magically appears. So we have different ways of collaborating with Neurodesk. The first one is a central instance model. This is commonly used in workshops and teaching environments where we use open data. So what we do is we install a central instance on, for example, cloud or on-premise infrastructure. We just need a virtual machine eventually and some storage. And then everyone just logs into the system and they can all collaborate on the same data, and it makes teaching a breeze. And the other model is where people run Neurodesk in their institutions. Again, this could be on a cloud infrastructure, could be on their computer. And then they aggregate higher level results on a central level without actually sharing the raw data. And this is fantastic for patient data, for multi-site studies. So we see a lot of people doing and using this model as well. And with this, I claim now that with this, installing, maintaining scientific software is actually type 1 fun again, because Neurodesk just organizes all of this software and provides us on all of these different systems. The only thing you need to do is install Neurodesk on the system, which sometimes can be a little bit of work, especially if you're like in a secure environment, you need to get this data in there. But once you got it in there and you got some help from HPC admins, for example, it's quite easy to use and it just works magically. So we have a lot of universities who deploy this on the high-performance computing clusters, for example. And we have a lot of people who run it on cloud as well. So just wanted to show a really new thing that we just did in the last weeks, which is now closing the loop. So we can actually now run Neurodesk containers on the MRI scanner. And this is really fantastic. So I quickly want to show that this will be, it's just submitted as an ISMM abstract. It's really very new results. So what we do here is we use an open format in the MRI world, which is called the ISMRM RD format, or just short MRD. And Siemens has implemented this open format, and they call it Open Recon as a product. So if you have a new Siemens scanner with XA60 or later than XA60, then you can just take our Neurodesk containers, and it needs a little bit of scripts around it to handle the streaming of this data. And then you can run pretty much any Neurodesk container on the scanner. The processing happens on the scanner. The results are output back into the database. So it's really fantastic because in the old days, I think still today, people take DICOM data off the scanner, process it on another computer, try to convert it back to DICOM, put it back in the scanner or back into the PAC system. And with this solution, we don't need that anymore. It really closes the loop. We can even get these containers FDA approved and then use them in clinical use and distribute them to clinical sites. So to me, this is an absolute game changer, what Siemens did there by supporting this open standard, and containers make it possible. So yeah, the steps are pretty simple. So we try to make it as easy as possible. You build a standard Neurodesk container, you package it for Open Recon, but just committing a couple of files into a repository. Everything is automated on GitHub, and then you get a zip file, you download it from the Siemens C2P platform and just deploy it on your scanner. So yeah, so we're currently just testing this with first customers, but this is really, really exciting. So customers, I'm saying customers of Siemens, not our customers, because we're an open source project. We don't have customers yet. So yeah, so before I go into the next step, I just saw a couple of questions there that I quickly want to answer. So the first question is, what about some toolboxes that work with MATLAB environment like SPM? It's included in Neurodesk. Exactly. So MATLAB is unfortunately a big pain for us because MATLAB needs a license. And what we've done is we basically included MATLAB in Neurodesk itself. So what you can do is if you have a MATLAB license, you start MATLAB, you register your license, and then MATLAB will work. So this is okay. The challenge is not everyone is privileged enough to have a MATLAB license. And what we do there is we compile, for example, these toolboxes. So SPM, Cat12, Con Toolbox, lots of these MATLAB toolboxes. They were really great. We compile them, or the developers compile them themselves, and then we package them with the MATLAB runtime environment. It's annoying because it creates a really big container. It's about 8 GB in size as soon as you take this MATLAB runtime environment. But it works. It's a way of working. And I hope that sooner or later, everyone moves away from closed source languages and adopts open languages. But as long as we don't have that, that's, I think, an option that we can support, and we try to help people there as much as we can. Yes, so the next question is, do you have a list of available containers with Neuro tools? And yes, we do have that. And I can show this in a couple of seconds as well when I do my live demo. And also, at some point, Neurodesk was using Neurodocker. So that's true. We're still using Neurodocker to package these containers. And we added recipes on top of that. And exactly. So basically, we use still Neurodocker, and we contribute to Neurodocker in the sense to, yeah, add new recipes, but we also add things on top of it. So yeah, it's still the base there. So good. So that's some questions for now. So let's move on to my next step in this talk. So here I want to talk about open data workflow in Neurodesk. So I quickly want to give you a summary of what's possible. So basically, the idea is you can import data from anything. So from DataLad, OpenNeuro, OSF, XNet, and then on any cloud provider, any cloud storage, process the data with any tool that's available, then organize it in Jupyter notebooks where you document what you're doing, and in the bits format, for example. And then about this section, there will be a talk from Tui in a couple of hours where she will show how to do a bits analysis or bits conversion with Neurodesk and a couple of tools that we have in Neurodesk for that. And then you can share this back to the community. This is ultimately our goal, right? We want open science, so we can upload these things to Google Colab, to OpenNeuro. We can use DataLad to pretty much push the data anywhere. We can upload to OSF, GitHub, and now with Open Recon, we can put it on a scanner, and we can really close that loop. And I thought that is really fantastic. And what I want to do now is I want to do a quick live demo of just showing how to download a data set with OpenNeuro using DataLad, process it with FSL, document a quick analysis in a Jupyter notebook, and then publish that notebook on Google Colab so you can use it in a paper. Let's see if I can do this in a couple of minutes. But before I go there, I just want to thank you for your attention. And yeah, we're just saying we need help. We're an open source project. If you have time at hand and some skill in this, please come and help us. And yeah, that brings us to the live demo. So what I want to show here is something pretty crazy. So I will show you our cool Neurodesk client. And this is a Neurodesk, we call this Neurodesk app. It's an Electron app that runs cross-platform. So here I'm showing this on a macOS system with an Apple Silicon. So this is actually a system that's really challenging to get any neuroimaging software to work. So what you can do here is you can select, quickly show this as well, in the settings, you can select which engine you want. So we currently support Docker and Podman. So Podman is an open source version of Docker. If you can't run Docker, use Podman. Also, Podman is currently a good choice on macOS with Apple Silicon because Docker just recently broke a couple of things and that we're just trying to fix. So there will be a new release very soon where this will also work everything again nicely with Docker. So then you can basically say, oh, I want a remote instance where you run on a cloud instance, or you can run I run locally. And I just want to show this. So locally, you click on this spins up a container on your computer, and then you can start a desktop, which we call Neurodesktop here. This opens a new window. And when you're really too fast, you get this little error. And what I've done here is I just scaled it up so much that we can hopefully see everything what I'm doing here. So what I want to show now is I want to take a data set from OpenNeuro. So I'll take the flanker data set and let's see, flanker data set. I'll probably have a typo in there, but it still works. That's good. So what I want to do is I want to clone this data set. So I want to quickly show you how easy this is. So I'll grab this, go back to my Neurodesktop command line. So you see it's just a normal desktop. And here I can say data led and data led install. And then I can just use this Git link. So what this will do is it will install this data set. And this went really quick, right? Because this just downloaded a couple of things. So what just happened? It just downloaded the references to files. So the files are actually not yet downloaded. So what you have to do is, as the next step, you have to go into this data set and you have to say data led get subject 08. And then if you type it correctly, which is one advantage of live demos, it will start downloading the anatomical file. This will take some time because this is now coming from the US over to Australia. But as soon as this anatomical file is here, it will start downloading the functional scans as well. So while this is doing this, I'll just quickly show you what we've got. So when we reload the folder, we can just double click on this file. It will open this file and we can see, hopefully in a second, there it is. We have an anatomical file. So that's really cool. Now, what I want to show is, I want to show that I can now do an analysis with this. So here is my subject scan. So now let's say I want to do a simple brain extraction. So BET, right? Now it says BET is not installed. So what does this mean? Well, we want to make it explicit what tool you're using. So you have to say you want FSL in a certain version. So for example, I'm picking FSL 7.8. Now I have BET available with exactly that FSL version. So now I can run BET on the subject. And BET needs as a first command the file name, and then as a second, the output file name. And then I'll just run it with this -R and -V option so we see what it's doing. And you see now it runs BET. And then in a couple of seconds, we should have a brain extracted version right here. And I can open this as well. And there it is. So we have our brain extracted scan. Fantastic, right? But this is not really open science because this is just tinkering, right? It's just tinkering on a terminal. It's fantastic for trying out things, great for learning, but for sharing analyses, this is not great. So what we want to do next is, but before I do this, I just quickly wanted to show you one thing because people often ask, how do I get my files now out of Neurodesk? And what we are doing here is we have actually a file, a directory that's shared between your host computer and Neurodesk. So I quickly show this here. So this is now a file system. In my file system, on my macOS system, I have a Neurodesktop storage directory. And in this directory, I can now, this is now linked to Neurodesk. So what I can do here is I can drag and drop this brain scan in there. And if I now open back up my Finder window, now here is my brain scan. And that's how you can exchange files between Neurodesk and your host operating system. There are many other ways. We described that on our website. So I quickly want to show the last thing here, which is now creating a nice reproducible analysis. So we like notebooks for this. And the reason is that notebooks are fantastic for documenting what you're doing. So what I will quickly do here is I will copy and paste a couple of things together. So the first cell is needed for later because I want to run this notebook on Google Colab. For Google Colab, I need some setup scripts. The next line is also just to show for reproducibility. So since I'm currently running on an Apple Silicon processor, it can't tell me what processor I have. That's just a limitation of the emulation we're using here. But later on Google Colab, it will tell us it's an Intel processor. And then I will get this data again from data.let. So you can also do a bash cell, which is quite nice. Since this data set was already installed, it doesn't have to redo anything there. So that's fantastic. And now what I can do is I can visualize this data as well. And this is a really fantastic package. You will hear more about this tomorrow from Chris Rawdon. And it's developed by Chris Rawdon and a big team around him. And they're building a native web viewer, which allows 3D rendering and visualization in every web application, including Jupyter Notebooks. So we use this a lot in Neurodesk to show and visualize data. Then we do a really cool thing. Again, we're using LMOD now to load FSL into our notebook. So now I can use BET inside this notebook. And another quick way, if you want to run a bash command, is having an exclamation mark in front. So what I'm doing now is I'm taking exactly that same scan and I will brain extract it, exactly what I did earlier on the terminal, just now that it's nicely documented and I can see what's happening. And then I can visualize exactly that brain extracted scan. Here it is. And now I see this even worked. So this is fantastic. This is a pretty okay brain extraction. It's probably the best you can get from BET and from this data. So this is really cool. And now I can say, okay, well, this is a really cool notebook. I'll give it a name, MRITogether, and I'll save this. And now I downloaded this on my computer because I want to give this to someone else. I want to give this to a colleague. So I'll just say download and I put it in my download folder. And now what I want to do is I want to go to Google Colab and I want to upload this notebook there. So here's my MRITogether that I just created and it's uploading. And then I will run this notebook on a completely different computer, which is Google Colab's computer. So I don't even know what processor I will be getting. So the first thing, we'll set up a couple of things and then we'll probably tell us what processor we're getting today. And then it will run the whole analysis. This will take 1 or 2 minutes. In this time, I would like to take some questions. And then hopefully, when we're done with questions, this is also done. And I reproduced my own analysis on another computer. So thank you all for your attention.
Thank you so much, Steffen. And this is where I sheepishly sit here and think, I have not used Neurodesk to its full extent.
Yes, I guess, yeah, it takes a while to see all the functions, and we're continuously adding new functionality as well. Like the Open Recon thing that has really happened while I was in Europe. We developed there a lot, and yeah, so there's a lot happening right now. Yes. And there is a question from Christian Montalba. Yeah, do you want to ask it?
Yeah. Amazing presentation, Steffen. I think these kind of initiatives are amazing because nowadays more and more people from like radiologists or neurologists like learn how to process neuroimages. And also it's very difficult. I don't know if you teach someone that doesn't have any computer knowledge or how to install I don't know, Linux. It's very hard, you know. So I think it's kind of amazing to download Docker and you have everything.
Yeah, exactly. Yes, it's a great environment for teaching and everything. And we still are fully aware that learning Linux and programming is too much for a lot of medical professionals and radiologists. So for this, I see Open Recon really as a great way of they don't have to learn it. Once it's coded up, it just runs automatically in the background. And I think this is how a lot of the good pipelines should work. And we're also still continuously working on making things easier and involving less code, but that's a lot of work because yeah, a lot of the things we do are coding, and yeah, so yeah. I think there's a question from Eva Reshi. Yeah, do you want to ask a question? Can't hear you yet. Anyone else? I hear something.
I'm not getting audio through, just as a sanity check.
Yeah, okay. So it's not us, Ibarishi. Not sure if you want to check your audio settings again or type it in the chat and I can read it out. Yeah, we definitely heard some noise when you unmuted. So some microphone is working, but we didn't hear you, unfortunately. So yeah, so while this is running, we now saw we got a genuine Intel, a Xeon CPU. So they gave us a machine and it has downloaded this data and it's now about to visualize it. So let's see if that works. It does. Look at this. So yeah, NeView is just absolutely fascinating library that's running the brain extraction. Yeah, any other question while we're waiting for the last plot?
Steffen, I'm going to ask, if one was to try and do online functional localization of brain regions at the scanner, is this something that would port well for that purpose?
Yeah, you could. Yes, exactly. I mean, there's definitely good software already on the different platforms to do online fMRI, but OpenRecon should be able to do this as well. Yes, if you have something really custom that the current fMRI tools don't support on the scanners, then this would be a way. Yes, you can definitely right away, so as soon as the image is acquired, so as soon as you have a 2D API, anything is reconstructed, you get this image into the container, you can do the processing, you can send it back to the database. So definitely it could work for these things. Yes. Okay, so the question that came through is Neurodesk free to use or is it subscription based? So Neurodesk is completely free to use. It's all open source. There's nothing you need to pay for. We can do this because we had a lot of grants, and that was really the sustainability talk from Eswin that he gave yesterday. We had lots of grants that support this. We have a lot of support from cloud providers that pay basically our bills right now. The challenge is, so we can currently do this and also for the next couple of years. The question is, how can we do this really, really long term? And for this, we do have a commercial, I would say, sustainability plan where, for example, if you want to run this at a conference and you have hundreds of users and you don't want to set this up yourself, you can go to the so-called Queensland Cyber Infrastructure Foundation and you can ask them to set it up for your workshop professionally, provide your support and pay a fee for that service. And some of this fee then supports back the open source project. But everything we do is open source and will hopefully always be available and always be supported. But it does cost money in the end. And currently we're very lucky that we have lots of supporters who pay the bills.